Yes, ma'am.
Yes,
Can
ma'am.
you hear
Good
me?
morning.
Yes.
Can you hear me better?
Yes, ma'am.
Yes.
Okay. So, good morning to all of you.
Good morning, ma'am.
Good morning, ma'am.
Good morning.
Thank you. And now we start. Yesterday, what we did, on Saturday, last week, what did we do, beta? Say, distance, displacement, speed, velocity, isn't it? These are things that we did. Now,
Yes,
today
ma'am.
we are beginning with acceleration. So, these are all parts of motion. Remember that. These are all factors of motion. How they are related, we are going to see one by one. Okay, start with acceleration. Start, Jishan.
Yes, ma'am. Acceleration is defined as the rate of change of velocity. It is a vector quantity and its direction is given by the direction of the force causing acceleration. Mathematically,
So,
acceleration is given as acceleration is equal to change in
velocity
velocity. Velocity
divided by.
divided by time taken.
Now, you have a vehicle. Do you have a vehicle? You want to speed up. You accelerate. Yes or no? There's a in the car also we have got a accelerator, isn't it? We increase the speed. Yes or no? Hello. If you are driving, if you are riding a bicycle also, if you increase the speed, that means we are accelerating the speed. We are increasing the speed. So whenever you are increasing the speed, that is called as acceleration. So obviously, the initial speed will be different than the final speed, isn't it? So there's a change in the velocity. There's a change in the speed. I hope you understand. So that change, that increase is called as acceleration. And obviously, it is a vector quantity. Why? Because direction is also important in this case. The amount and the magnitude as well as the direction is important in acceleration. The equation of acceleration is change in velocity. What is the change in velocity? That means it should be the final velocity and the initial velocity upon the time. It could be t or it could be t2 minus t1. Is it clear? It either could be only t or t2 minus t1. I hope you have understood this because time taken is also should be change in time, isn't it? If change in velocity is v2 minus v1, then the change in time taken will should be also t2 minus t1. This is the formula of acceleration.
Ma'am, please
Yes.
explain.
What? Which one better? Acceleration again.
Yes, ma'am.
Fine. Now a body is moving from here to here, right? Let us come here. This is
Yes, ma'am.
A and this is B. Okay? The time is 0, the time is 2 hours. Is it clear now?
Yes, ma'am.
Yes? Change in velocity, obviously this is initial speed, it is at rest, so the velocity has to be 0. You agree or
Yes.
not? Okay.
Yes.
And over here, at the B, it is, for example, take it as 4, right? 4 meter per second. Sorry, only 4 meter. Is it clear?
Yes. Yes,
Velocity is
ma'am.
4 meter per second. Now, change in velocity will be 4 minus 0. Yes or no?
Yes, ma'am.
This 4 minus 0 divided by time taken is 2. 2 second, for example, say 2 second. So it is 2 minus 0. Agree? Answer will be 4 upon 2 is equal to 2 meter per second square. This is the unit of acceleration, meter per second square. Because this is meter per second and here it is second. Okay? Velocity's unit is meter per second. I hope you know that.
Yes.
Right now, uh, just hold on a bit with that. Okay.
Okay, ma'am.
Yes. Continue. So it is 4 meter per second. That's the velocity unit divided by 2 seconds. This second will go up, it will become second square. Is it clear? We will do the numericals later, so you will understand. This much is clear,
Yes, ma'am.
Kishan? Okay. Rest of you, Septain,
Yes,
Sadin,
ma'am.
all of you have understood?
Yeah, ma'am.
Now we will do this. Read it better. See how to do the numerical. Read better.
So,
Yes. Start.
declaration is equal to
No, no,
VU.
not that. Suppose the velocity of a car is that you have to begin.
Suppose the velocity of a car is a time
You,
at time
you.
t1 letter at time t2. Its velocity become v. Change into velocity is equal to v minus u time interval t2 minus t1.
Okay. That means what it is saying, suppose the velocity of car is u at time t1. So at time t1, the velocity is u, right? And at time t2, the velocity is v. So obviously, which one is final? This is final. So we have to minus initial from final. What do you say? So we have to take this as first, isn't it? So we have taken V. We have to take this as first. We have taken T2. Hope you have understood. And then T1 over here and then U on top. Is it clear? So from final, please put off your mic. So from final, we are subtracting the initial. How we have done that? Final velocity is V. Initial velocity is U. So V minus U. Final time is T2. Initial time is T1. So T2 minus T1. This is how you have to remember. This is the formula. The final velocity, the initial velocity, the final time, and the initial time. Is it clear? So acceleration
Yes, ma'am.
exactly is actually how we write acceleration is equal to v minus u upon t. This is what we write actually. But when we have been given two time, that is final time and the initial time, then we have to take it as 2 to t2 minus t1. Otherwise, only t is okay. Understood better?
Yes, ma'am.
Understood? Okay. If you have any problem, like how Jishan asked, all of you are supposed to be asking me the same way, okay? Now we will do some graph. This is pertaining to acceleration. Yes, better start.
If the rate of change of velocity remains constant, then the
Constant. Better, please read properly. Constant.
acceleration is uniform.
Hmm.
Example of uniform acceleration include a ball under free fall, a ball rolling on a inclined plane, and a car accelerating on a straight traffic-free road.
Okay. Now, what does this suggest? Can you explain, Sipten? Can you explain? For example, over here, let's see the graph. Now, this line, can you see this line straight? It's going straight. It is constant, the rate of velocity, because velocity is over here. Can you see this velocity?
Yes,
Yes. So it could be time is here 1 hour, 2 hour, 3 hours, 4 hours. It is a straight line. The velocity is same. It can go to 10 hours also, the velocity will be same. That means we will say that the acceleration is uniform. You understood now?
Yes.
Whatever be is the time, the speed, the velocity remains the same. So we will say that the acceleration is uniform. Okay? For example, I leave a ball. Now you go on a terrace, you take a rubber ball and you just leave it. The uniform, it will come down with uniform acceleration. Inclined plane, for example, this is an inclined plane. You have a ball over here, let it roll. It will have a uniform acceleration. Okay? Then let's take an example of a car where there is no traffic. A car is moving on a straight road where there is no traffic. It will have a uniform motion. Understand?
Yes, ma'am.
Now see the other one. So we are going to differentiate between the uniform motion, sorry, uniform acceleration and non-uniform acceleration. Read better.
If the rate of change of velocity changes with time, then the acceleration is non-uniform. Example of non-uniform acceleration is a car accelerating on a straight road with traffic.
Hope you have understood.
Yes,
Yes,
ma'am.
the difference? Okay. For example, again we do the same. Now over here, one, two, three, four, five, right? One, two, three, four, five, right? See how it is moving. It's changed. The velocity is different. At one it is different, at two it is different, three, everywhere it is different. So obviously it is non-uniform. Acceleration is non-uniform. The example that you have observed over here is a car which is moving on a road, but it has got traffic. So sometime it moves, then it stops, then it moves slowly, then it moves fast, then again it stops. Hope you understand. If there's a traffic signal, it has to stop. Do you understand? So it is a
Yes.
non-uniform acceleration. Any problem? Tell me. Have you understood the difference
No,
between
ma'am.
uniform acceleration and non-uniform acceleration? All of you have understood?
Yes.
Disha, do you have any problem? Hello? Dishan, do you have any problem?
No, ma'am.
Okay. Now we'll see types of motion.
Motion.
Okay. Now we'll see types of what we did right now. The paths of motion. The acceleration was the last. We started with velocity, we started with distance, displacement, speed, velocity, isn't it? Acceleration. Everything is over now. Those are the parts of motion. Now we'll see types of motion. Now it can be classified into three categories. Please read. Please read.
Translatory motion is the motion of a particle in a straight line. A bus travel on a straight road and a apple falling from the tree are example of this kind of motion.
So that means what is important over here? What is
Straight line.
important? Straight line. So translatory motion is always in straight line.
Straight
So
line.
bus moving on a straight road, apple falling from a tree in a straight line. All these are the examples of translatory motion. Is it okay with all of you?
Yes, ma'am.
Okay. Now we come to rotational motion. Read better.
Rotational motion refers to the motion of a body around a fixed axis. A spinning top, a bead moving on a circular track, and the Earth's rotating are example of
Dishan,
this
better read
kind.
properly. Please read
Rotation
properly.
are examples of things, kinds of motion. These kind
Okay.
of motions.
Thank you. Rotational means, as the word says, it is rotating.
Hmm.
It is rotating around a
Earth.
fixed axis. For example, you must have played with, you're still playing with tops, I think, the spinning top. You know the
Yes, ma'am.
top? Okay, so you picture how it rotates, that is rotational motion. A bead. You know what is a bead? It's a
No?
part with which we make necklace. In
Mm.
Hindi, it is called as moti.
Yes.
Yes. So bead is a moti. If you move it, it also rotates on its axis. And the third example is the Earth's rotation. I think you know that Earth revolves around the sun and Earth rotates around this axis. Yes or no?
Mm.
Earth
Yeah, no.
rotates on its axis. It is a bit
Axis.
tilted. Yeah, it is tilted. Remember that, right? It is revolving around the sun as well as rotating on its axis. Got my point? So that is
Yes.
also a rotational motion.
Motion.
Now we come to period. That's periodic motion I've already taught you in 8th standard, if you remember. Yes, say periodic motion.
Periodic motion refers to the motion that is repeated in a regular interval of time. An oscillation spring on
Oscillating.
and the
Oscillating.
oscillating spring and the motion of planet around the sun issue
Illustrate.
illustrate this type of motion.
Now periodic motion is what? It is happening at regular intervals and it is being repeated.
Yes.
Yes? For example, you see the clock, you see your watch, hour is 60 minutes. Is periodic, yes or no? How the arms of the clock moving, how the arms of your watch moving. It is periodic, isn't it? 1 hour is fixed, 60 minutes. It will never be 61, it will never be 59. It is periodic. What do you say? Second one is your swing, what we call it as jhula, swing. Yes, even you enjoy playing in the swing. So it is also periodic motion. Yes, the wall clock. You got the pendulum? I told you, you got the pendulum? I'll show you this one. This is the pendulum in the wall clock, right? It goes over here
Yes, ma'am.
and it goes over here. Got it? Like this. So this is also periodic motion. So the motion which is repeated and in a fixed interval of time is called as periodic motion.
Motion.
Okay? Earth moving around the sun is periodic. How many days? 365 days. It never changes, isn't it? Okay?
Yes.
So types of
Yes,
motion,
ma'am.
you can say random motion, translational motion, rotational motion, oscillatory motion. Oscillatory motion is also called as periodic motion. Then in translation motion, you got the rectilinear motion, curvilinear, and circular motion. We will not go in detail, but mainly I just want to show you, just want to give you a glimpse. The types of motion are translational motion, rotational motion, oscillatory motion, and random motion. But we are not going to. Now, what are random motion? What are random motion? Can you say what could be random motion? For example, there's a butterfly, right? The butterfly is not following a path, it goes anywhere. When it goes anywhere, it is called as random. You understood now?
Yes.
There's no path as such. That's why it is called as random. For example, there's a particle. There's a particle, another particle over here. It comes in remember diffusion I taught you? It comes, it collides with it, and then it goes over here. So randomly it moves. It can go here, it can go here, it can go here. Anywhere it can go. So the motion is random over here. There is no fixed path. That's what is called as random motion. Okay? Is it fine? If
Yes,
you're
ma'am.
not able to understand, you can stop me. Please. Fine or no?
Fine,
Yes,
ma'am.
ma'am.
Now we'll do one by one. What did we learn earlier? Translatory motion. The other name of translative motion is linear motion, straight line. You got it? So never be confused that if I say translative motion and if I say linear motion, you will be confused. No. Straight line is translatory or linear motion. You understand?
Yes, ma'am.
Okay. Let's read.
Linear motion. The word linear means straight and the word motion means change in position with respect to a frame of reference. So a body moving in a straight line with respect to a frame of reference is said to be in linear motion. An example of this is the motion of an ant on a straight wire.
Fine. So we know the linear, the word itself
Mm,
means straight. Linear means straight. And motion, we know that change in position with respect to time. The reference is time. I think you know that. Change in position with respect to time. So body, when it is moving in a straight line with time, it is said that it is in linear motion. You must have seen ants moving in a line. Have you ever observed ants moving in a line? Hello?
yes, ma'am.
Have you
Yes,
ever
ma'am.
observed ants moving in a line? That is a
Yes,
linear motion. That is a linear motion.
ma'am.
So you can see over here, this is linear motion. It's going straight. The girl is running in a straight line. Okay, now read.
Points to remember regarding linear motion. In linear motion, the object must move in straight line. The motion of the object along the straight line may not be uniform.
Okay. So now the second point is that it may or may not be uniform, depending upon if an ant is moving in a straight line. Now if I stop it, if I put something in between, if I put a drop of water, do you think the ant will move in a straight line?
Amen.
No. It will stop and will take a safer direction. It will turn or it will curve or it will change its direction. Yes or no? But the rest of them will follow. The ant which will change its direction will be followed by other ants. Remember that. Okay?
Yes, ma'am.
Again, it will be a straight line. So in linear motion, the object has to move in a straight line. But regarding the motion, for example, you can see over here. See, the motion is okay. Again,
Okay.
it has increased. Now it has increased so much. So it is changing.
Yeah.
The motion is changing. Yes or no?
Yes, ma'am.
The velocity is
Yes,
changing.
ma'am.
Can you see this? With the time. So it may or may not be uniform. Again, I'm giving you certain more examples of. So that's why I'm using all different notations or different words. What we did last was linear motion. What we did with the linear motion. The
Linear
same thing
motion.
has been same. It is translative motion is equal to linear motion. But here, what purposely I've used the word translatory. Okay? Yes, read better.
Translatory motion is the motion of a particles in a straight line. A bus travel on a straight road and an apple falling from a tree are an example of this kind of motion. Ma'am,
So
it's
now
like
it's clear.
that.
Yeah. What happened?
It's
Yeah.
like
So you
that.
can see. Yeah. You can see this apple falling from a tree. So it is same as we have already done earlier. So
Yes.
translatory motion is equal to linear motion. So that you put it in your mind. Because I may ask you linear motion. Then you will say, ma'am, you have not taught us. We have been knowing only regarding translatory motion. So that is what I'm telling you. So be aware of all these terminologies. I don't think I have to explain this anymore.
Mm.
Okay. Now we come to rotational
Rotational
motion.
motion.
Yes, read.
Rotational motion refers to the motion of a body around a fixed axis. A spinning
Same
top,
thing.
a
It is
bead
the same
moving on a what
circular
one?
track. It is the same thing. We have already done it.
Yeah, a spinning top bead moving on a circular track on the Earth's rotation are example of the kind of motion. It is the same, ma'am.
You can see over here. This
Yes,
is
ma'am.
the body, and this
Hmm.
is the direction of the movement. So it goes from here. You see this, and again it comes back. This is rotational motion. It comes back over here. Okay. What is this motion? This is called as rotational motion. Now we come to periodic motion. Read.
Periodic motion refers the nation that is
Repeated.
repeated in a regular interval of time and oscillation spring
Oscillating.
and
Better read properly, please.
oscillating spring
Spring.
and the motion of planet around the sun
Elaborate
illustrate this type
this
of
type of
motion.
motion. So it is periodically happening. It is
Yeah.
periodically happening with time.
The word linear
This
means
this this we have already done.
yeah.
I just want to show you this picture. See. Can you see this picture?
Yes.
How it is moving? It is moving in a straight line. This is how you have
Straight
to
line.
remember. It is moving in a
Mm.
straight line. This is linear motion. Okay? Don't yawn. Now we'll talk about uniform motion and non-uniform
Uniform.
motion. Is Jishan, why are you not reading Vita? Is he there?
No, he left.
Okay.
I'm
Fine, continue.
shifting.
Vita. Yeah.
Uniform motion. If a body
Sipin wants
travels,
to read? Sipin wants to
yeah,
read?
if you say,
Sipten is already reading.
He's already reading. He sounds same as Sarim.
no,
Okay.
ma'am, I already lead.
Okay. Then
Uniform
who wants to
motion.
read? Who wants to read? Sipin. Sipin, you're carrying on, right?
Yes.
Okay. Carry on, Vita.
If a body uniform motion. If a body travels equal distance in equal intervals of a time, it is said to be in uniform motion.
Okay. That means I will show you the example. This is A, this is B, and this is C.
See.
This is 1 hour. This is also 1 hour. Right? Now from A to B, the object travels. It takes 1 hour. Same distance. For example, let's say it is 2 meter, and here it is 4 meter. So this is also 2 meter. Yes or no? So this 2 meter, it takes 1 hour. This
One.
2 meter, again it takes 1 hour. So equal distance, equal time.
Oh,
This called as uniform motion. Understood?
yes. Non-uniform motion. If a body travels unequal distance in equal intervals of a time, it is said to be an in non-uniform motion.
Fine. Now see. A, B, C. Right?
Yes.
Okay, beta? Now from here to here it is traveling. This is 2 meter. This is 3 meter. Okay? But the time is 2 hours. The time is 2 hours. Understood now? Time remains the
Um,
same, but the distance covered will be different.
Yes.
Okay? So this is what is important. Maybe here there is traffic, maybe here there is no traffic. So the distance covered was more. Understood now? The time remains the same, but the distance changes, unequal distance that becomes non-uniform. What it becomes, beta?
Non-unit.
Non-uniform. Now let's read speed.
Speed of a body is the distance traveled by the body in unit time. Speed equal to time.
No, speed is equal to distance upon time.
Distance
How
upon
can it
time.
be time? It is written over here the distance traveled by the body in unit time. If it is written in unit time, that means it is to be divided by time, isn't it? So
Yes.
read properly with that.
Speed is equal to distance by time. If a body travel a distance in
S
time
S.
as
Read better.
in
It's written
time,
here. S yes, written here.
yeah, distance as in the time t, then its speed v is equal to s by t.
Hmm.
The SI unit of speed is the meter per second,
Or
ms or
or
ms or
inverse. Meter second. Don't say ms.
meter second or
Meter
ms.
second. No, no. Meter second inverse. Say
I not understand that one.
yeah. It is maths. This one is maths. Meter
Mm,
second inverse. What is
mm,
inverse? 1 upon s. Isn't it? 1 upon
yes,
s. Now, 1 upon s can be written as s inverse. You understand?
yes,
Fine. So, what is speed? Speed is the distance traveled per unit time. So, speed is equal to distance upon the. All this you have to mug up now. You have to remember. Okay? So, distance is s. If we take distance is s, then v is equal to s upon t. Okay? S upon.
yes, ma'am.
So this is speed. Now what is it? What is S? S is distance is equal to m meter.
M.
What is time? It is second. So it is meter per second. You can see how you got it from the unit that you take. So it is meter per second or meter second inverse. Any problem? Any
Non.
problem? Okay. Say, read.
Average speed is the ratio of the total distance traveled to the total time taken.
No, you did not read since speed has only magnitude. You did not read that.
Yes. Average speed equal
No,
to
no,
total
read.
distance
No, read
um,
since speed has only magnitude.
from again.
Yeah, since speed has only magnitude, it is a scalar quantity. The last line you did not read, so I'm asking you to read it.
Ma'am, the S unit of speed from that
No, no, that you have done. The
since
last line.
since speed has yes ma'am okay since speed has only magnitude is it is a scalar quantity.
Quantity. Because see, there is no direction. Is there any direction over here? No. It
No,
is not important. So only magnitude is important. How much? How much? 2 meter per second, 4 meter per second. How much is there? So that becomes scalar quantity. Now let's see what is average speed. Read.
average speed is the ratio of the total distance traveled to the total time taken. Average speed equal to total distance traveled by total time taken.
So understood? What does the average means? Total.
Yes,
If I find that, what is the average of this class? Ninth standard. What you will do? What you will do? Okay, I want to ask you what is the average height of your class? What you will do? Haven't you been taught in maths better?
mm,
First, you will
yes,
count all the heights, then we will divide by number of children. Do you understand? The total number of children. So, total height divided by total number of children will give you the average height. You
yes, ma'am.
understand? So, this is the
Yes, ma'am.
same way. Speed will be how much distance? Speed is equal to distance upon time. We know that. So, total distance covered divided by total time taken. For example, I go to Ahmedabad, I take 3 hours going to Ahmedabad, and while coming back, I take 4 hours. You understand? How
Yes,
much
ma'am.
distance is traveled that I will count and I will divide it by time taken and I will find the average. Got it?
Yes, ma'am.
Okay, I think we come to close of today's lecture. More in detail we'll do later tomorrow. Okay, beta?
Okay.
But I
Yeah,
wish
ma'am.
that all of you please go through